Hello dear students, this is Ikhlaq sir back with one mesmerizing problem in physics. Okay, and this question has been asked 3 times, twice in JEE Mains and once in JEE Advanced. The question is like this: there are two charged particles, two charged balls having charge q, mass m. They are connected to this rigid support with the help of two strings. So because of the force of repulsion, they will move away from each other. Then what next is there is that this whole system is dipped inside a liquid. That makes the problem a bit more interesting. That this whole system is dipped inside the liquid whose density is given to us, and the angles will remain same. The theta, that is the angle with the string mixed with the vertical, that remains same. The theta remains same, and we are supposed to calculate what is the dielectric constant of that liquid in which the whole system is dipped. Okay, so it is, I can say it is a problem on electrostatics, it is a problem on NLM, it is a problem on fluid mechanics. So many concepts are involved in this problem. So let's try to do it. First and foremost, let's assume that it's in vacuum. So when it is in vacuum, can you tell me how many forces are there on one particle? On this particle, there will be electrostatic force of repulsion like this. Let me name that as F. All right. There is weight, gravitational force in the downward direction, m multiplied by g. Okay, I can write down this mg like this. Do you know that density of object is equal to volume into density? Density is equal to mass by volume. So mass will be obviously equal to density into volume. So I will write like this: it is equal to sigma into v into g. Can I write it like this? Why? What is this sigma? This sigma is the density of one object. Okay. Is there any other force on this particle? Yes, of course there is, and that is the tension in the string. So the tension in the string will be along this direction. This is RT. All right. So how many forces are there on one particle? There are 3 forces. Now you can tell, sir, there will be one more force, that is the gravitational force between these two particles. But let me tell you that the gravitational force is there, but that can be easily neglected. That is uska magnitude बहुत कम होता है. So we have constructed the free body diagram of this particle. We have shown all the 3 forces on this particle. Now see that among the 3 forces, one force is neither vertical nor horizontal. So that is tension in the string. Next, what I am going to do is that I will try to resolve this T into the rectangular components. So let me do that. So if this angle is theta, obviously this angle is theta. Now T can be resolved. So ये वाला component होगा T cos theta. And this one will be what? It will be T sine theta. All right, T cos theta and T sine theta. Now see that the particle is perfectly in equilibrium. When it is in equilibrium, that means the net force on this particle will be equal to 0. When it's equal to 0, so that means the force towards right will be equal to force towards left, and the upward force will be obviously equal to the downward force. All right. Once we equate this T sine theta equal to F and T cos theta equal to mg, let's do that. T sine theta comes out to be F, and what about T cos theta? That will be equal to m multiplied by g, isn't it? All right. What I have done is that I have divided the 2 equations. This T and T will disappear. Sine theta by cos theta comes out to be something like this. That is tan theta equals to F divided by m into g. All right. So this is my equation. That is tan theta is equal to F divided by mg. I hope that it is clear to you till now. Now have a look. Let me rewrite this equation. Tan theta is equal to F divided by mg. This m will be easily replaced by sigma into v into g. Okay, so this is our equation in vacuum. In vacuum, this is our equation. Okay, when the 2 charged particles are separated by vacuum, this is the equation. Tan theta equals to F divided by mg, and m is equal to density into volume, which is sigma into v into g. Okay, now let's move back to the problem. Now the question is, now that is the more interesting part, and that is, if this whole system is dipped inside a vessel and that vessel contains some liquid, then the angle remains same, and we are supposed to calculate what is the dielectric constant of that liquid. Okay, now you tell me, when we will dip this entire system inside the liquid, do you feel that any force will change on this particle? Yes, of course. Number first is that electrostatic force is going to change. Why? The reason is that this electrostatic force is a medium dependent force. Number one. Number second is that there will be one more force, and that force will be what we call as buoyant force, and that will be directed vertically upwards, isn't it? So let's add those two forces. Once we dip it inside the liquid, we have two more forces on this object. Number one, this force F is going to change. It will be replaced by F by K. Whenever two charged particles are separated by vacuum, the force is F. If they are separated by any other material medium, the force will be equal to F divided by K. What is this K? Dielectric constant. The force will weaken and it will become F by K. Okay, number one. Number second, what about buoyant force? Buoyant force will be in the vertically upward direction. Vertically upward direction will be buoyant force, FB. Do you know what is the expression for the buoyant force, which follows from the Archimedes principle? That is rho into V into G. What is this rho? The density of the liquid. So it will be rho Vg, where V is the volume of the object, G is acceleration due to gravity. Now see that, number one, the force F is going to change. Number second is that there is a part of a force which is we call as buoyant force, which kills a part of weight, which is opposite the weight. So what I will do is this. What I'm going to do is this. In the liquid, the equation becomes something like this: tan theta. First and foremost, this F will be replaced. It will be replaced by what? It will be replaced by F divided by K, isn't it? Number one. Number second is that in the vertically downward direction, there is weight, which is sigma into V into G. And in the vertically upward direction, there's a buoyant force, which is rho into V into G. So the net force in the vertically downward direction will be sigma Vg minus buoyant force, which is rho into V into G. All right. Okay. Let me make this equation a bit more beautiful. Tan theta is equal to F divided by K. Then here I am going to write it like this: sigma minus rho multiplied by V into G. Now this is our equation number second. And this equation number second is true when the whole system is dipped inside a liquid. So let me write it here. It is in liquid. So the first equation we have is in vacuum, and the second equation we have in liquid. I'm sure you are following me. Next, what I'm going to do is that I'll compare the two equations, obviously. So the first equation, see that the LHS of the two equations is same. That is, first equation is exactly equal to second equation. See that tan theta, here it is tan theta, here it is F, here it is F, here it is V into G, here it is V into G. So what is the difference? The difference is this: here we have sigma, and here we have K multiplied by sigma minus rho. So obviously the sigma will be equal to K into sigma minus rho. Now can you tell me what is the dielectric constant? That's obviously equal to sigma divided by sigma minus rho. This is the answer to the problem. Okay, so I'm sure this is crystal clear to you. See you next time with another brainstorming problem in physics.